Welcome back. So if you spent, any time at all online or watching the news lately, you've absolutely heard the constant buzz around machine learning. It is literally everywhere. But it's also wrapped up in a ton of complex jargon, super intimidating math, and frankly, way too much hype. Today, we're stripping all of that away. We're going to break down exactly how this tech actually works by looking at the 4 standard analytical tasks it performs. And by the end of this explainer, you're going to see that behind all those fancy buzzwords, it really just comes down to 4 incredible ways of finding patterns.
So, what is machine learning really? First off, I want you to completely forget about the sci-fi movies for a second. Seriously, forget about the magic robots taking over the world. Instead, think about how algorithms actually understand and process our reality. It's not about machines suddenly becoming sentient. It's actually about a highly systematic, insanely fast method of sorting through mountains of information to find connections that a human brain would just take way too long to spot.
Okay, let's dive into this. At its absolute core, machine learning is simply a process of extracting hidden, useful, and non-obvious patterns from huge datasets using automated algorithms. That's the secret sauce right there. Think about it. If an expert could just look at a spreadsheet and easily spot a pattern, like, say, noticing that sales always spike in December, well, you wouldn't need machine learning. The time and effort required just wouldn't be worth it. But machine learning becomes an absolute game changer when the patterns are so incredibly complex or the sheer volume of data is so massive that a human simply couldn't find those non-obvious connections.
To make sense of all this data, we're going to look at 4 pillars today: clustering, anomaly detection, association rules, and prediction. Let's look at how the intimidating jargon usually boils down to these 4 tasks.
Starting with Pillar 1, clustering.
Think about how we naturally categorize the world around us, right? By color, shape, or purpose. Well, algorithms do the exact same thing with raw data on a massive scale through clustering. Imagine you've got a giant database of thousands of customers. A clustering algorithm will analyze all their attributes and automatically group together individuals who display similar purchasing habits, shared tastes, or identical preferences. In the business world, you'll often hear this called customer segmentation. You aren't just looking at a random list of buyers anymore. You are revealing distinct, hidden demographic profiles that you can perfectly tailor your marketing towards.
Basically, clustering can divide a massive, super confusing user base into really clear, actionable segments. For instance, you might discover a tight cluster of high-value spenders who buy your premium products every single month. Then you might see a larger cluster of occasional shoppers who really only buy during sales, and maybe a group of inactive users who are probably just one ignored email away from leaving forever. Identifying these specific clusters is a massive business opportunity, simply because you can now target each specific group with completely different, highly customized strategies.
Moving on to Pillar 2, anomaly detection.
Now, this is almost the exact opposite of clustering. Instead of finding the normal patterns where everything naturally groups together, we are actively hunting down the highly unusual ones. The algorithms learn what a routine, quote-unquote, normal event looks like daily grocery store transactions or standard medical insurance claims. And this brilliantly illustrates the core concept. Once the algorithm knows what normal is, it essentially acts as a tripwire for anything strange. A massive transaction in a foreign country you've literally never visited, or an insurance claim that combines highly unusual codes, the algorithm flags those outliers instantly. This is precisely how banks catch credit card fraud in real time.
Next up is Pillar 3, association rules.
Have you ever wondered how your favorite online store or streaming service seems to know exactly what you want to buy or watch next? I mean, it feels a bit like magic, right? But it's actually just association rules at work, often done through something called the a priori algorithm. And it basically works like a simple 2-step recipe. Step 1. The algorithm scans millions of shopping baskets to find items that frequently appear together, like, say, noticing that hot dogs and ketchup are bought together all the time. Step 2, it creates probability rules. It literally calculates the likelihood that if you buy item A and item B, you will also buy item C. So if a grocery manager sees a strong rule connecting these items, they might just place the ketchup right next to the hot dogs to drive up those sales.
And finally, Pillar 4, prediction.
Prediction uses all the historical data we've gathered to estimate unknown values or guess what will happen in future events. But I really want to clarify right now that prediction isn't fortune-telling. In machine learning, it's generally split into 2 distinct types. The first is classification, where the algorithm predicts a specific category. Is this email spam or not spam? Is this customer going to cancel their subscription or are they going to stay? It's all about categorizing outcomes. The second type is regression. Regression predicts a continuous number. Think about estimating the price of a house based on its square footage and the number of bedrooms, or predicting the resale value of a used car based on its mileage. So one predicts a label and the other predicts an amount.
Now, what's really interesting here is how a decision tree model acts as a highly effective tool for classification. Let's say it's built to filter out spam emails. It works by asking a series of branching questions. It starts right at the top. Is the sender unknown? If yes, it moves down a branch and asks another question. Are there suspicious words? Based on the combinations of these attributes, unknown sender, suspicious words, strange attachments, it reaches a final conclusion on the tree, classifying the email as either valid or spam.
A rule like, if an email contains the phrase "make money easily," it is likely spam, well, that's completely obvious to us. A human could write that rule in 10 seconds flat, but a human can't process 1,000,000 emails a minute. Machine learning handles thousands of these attributes simultaneously. It can track incredibly subtle patterns across hundreds of variables, time of day, tiny misspellings, complex routing addresses to make incredibly accurate instant predictions that a human rulemaker would entirely miss.
This brings us to the power of patterns.
When you completely strip away the hype, machine learning is really just an incredibly efficient pattern-finding tool built on these 4 pillars, happening all around us. It isn't some impenetrable mystery. It's a set of highly logical tools applied to data. Whether it's clustering customers into segments, detecting anomalies to stop fraud in its tracks, using association rules to recommend your next purchase, or predicting future outcomes through classification and regression, these tasks quietly shape our digital experiences every single day. So I want you to think about the information surrounding you right now in your business or just in your daily life. What hidden, non-obvious patterns is your data just waiting to reveal? If you apply the right pillar, you might just find out. Thanks so much for joining me on this explainer, and I will see you next time.